My name is Alex Main, and I am doing an overview of cybernetics. Now, contrary to what you might think, cybernetics doesn't just deal with advanced implants and neural net imitators. It's actually a study of closed signal loops, which basically means things that affect themselves. So, self-modifying systems, basically things that can control themselves. The term was first coined by Plato in the Alcibiades, written a long time ago, and it originally meant something like a conductor or a master steersman. And anyway, the first closed signal loop that you can consider was made by a guy named Ketsibos, which made a water clock, which was able to regulate the amount of water that was put into it. It was able to drain if there was too much or fill up if there was too little. Anyway, Norbert Wiener was one of the main driving forces behind modern cybernetics, as he wrote a book, ironically enough, titled Cybernetics in 1948. He connected control with communication, as in you can't have effective control without communication. And cybernetics split from AI research at the 1956 conference. AI technology is artificial intelligence, basically the creation of a new consciousness, a new mind that's capable of thinking and learning independently of whoever created it. Anyway, the two methods to create it are either to emulate what the human does when they attempt to solve a problem, or essentially distill rational thinking down to a series of equations. There are many methods of testing whether or not something is self-aware and thus an AI, such as the Turing test, but none are really considered to be a catch-all test. Bionics is the implementation of a function found in nature. Essentially, you study something and attempt to emulate it using technology. It may or may not copy the specific structure used in nature, but it generally follows the same principles, such as a Velcro or the saw edges on lumberjack blades, cat's eye reflectors, which are the devices put in the road where reflect light when it's shined on them, so you can see at night. And generally, this is anyway. Biomedical engineering is the application of biotics in a setting. It's basically a more specialized field. It deals with stuff such as prosthetics, implants, dialysis, and various sub-studies in it are tissue engineering, genetic engineering, pharmaceutical engineering, and neural engineering. Systems biology is the study of interactions between systems as a whole, rather than just individual interactions between organisms or specific reactions occurring within an organism. It's kind of a specialized field, and it's kind of coming out of favor because of several new fields, which are essentially systems biology. Autopoiesis is the study of self-replicating organisms. It's kind of defunct now, considering how almost every organism on Earth is self-replicating. So people who study autopoiesis generally study artificial self-recreating machines. And it's kind of hard to put specific advantages or disadvantages to cybernetics because, contrary to what I thought when I originally researched this, it's not a specific topic, rather it's a general area of study. So there are no real advantages or disadvantages you can apply to such a general topic. So, and this is my sources.
Alex, you have a question?
Yes. Is cybernetics kind of like the things where it's the artificial limbs that are connected to the nerve endings and amputated limbs that are able to move.
That's biomedical engineering, which is part of cybernetics, yes. It's pretty cool. Anything else?
Any other questions?
No.
Okay.